In this video, we'll talk about and compound inequalities. So as we mentioned in the last video, a compound inequality is two inequalities written with either the word or the word and. We've looked at the case with the word or, and now we'll focus on the case with the word and. When we think about and, I want you to think about both. This is described as the intersection or the overlap of two inequalities. We want the solutions to satisfy both of the inequalities. It can't just be one, it has to be both. When we're graphing, we're only going to graph the region where the inequalities overlap. If they do not overlap, then the solution set is empty. So we're going to begin by graphing. We'll look at these two examples. Each of them have already been solved for the variable x. We're going to focus on how to graph and how to do the overlap. All right, so the first example was x is less than or equal to 5 and x is greater than 0. So we're going to do this graph in two stages. We're going to make kind of a sketch graph first, and then we're going to draw the actual graph. So this first number line is just our sketch. The two numbers are 0 and 5. 0, 5. I'm going to draw both of these inequalities on the same number line. I want to focus on where they overlap each other. So for the x is less than or equal to 5, I'm going to shade this one in blue. So x is less than but equal to 5, equal to bracket less than, I'm shading to the left. Next, I'll graph x is greater than 0, and I'm going to graph that in red. So greater than, not equal to, so I have parentheses at 0, and then I'm shading to the right. Now I only want the overlap. The overlap is the and. These are the values where the solutions in this region work for the x is less than or equal to 5 and work for x is greater than 0. So my actual graph, my actual solution set, will only focus on the values between 0 and 5. Now, when I am graphing, I still need to think about whether or not 0 and 5 are included. Use the same endpoint, so 0 has parentheses, 5 has a bracket, and I'm shading all of the values in between. So this is my solution set. I could write that as an interval as well. This would go from 0 to 5, including 5. Taking a look at this second example, x is less than 8 and x is less than 6. So I'm going to draw a sketch first. This will be my sketch. Putting the two values, 6 and 8, 6 is smaller, so it goes on the left. For the first inequality, I'll shade that in blue. X is less than 8, not equal to, so I have parentheses and less than. Keep shading so you go all the way to the end of your number line. Well, not necessarily the end, but the end of the drawing of it. So you want to make sure you do see the overlap. Just because you don't draw something that has overlap doesn't mean that it doesn't eventually. X is less than 6, I'll draw that in red. Less than shades to the left, and I want to not include 6, so parentheses at 6, shading to the left. All right, now where do these overlap? These overlap in this region. So my and happens over here. This is where they're overlapping each other. So my actual solution set, there's 6, there's 8, is where are they overlapping? They're overlapping from 6 and smaller, not including the 6 because the 6 is not included in this inequality. So I'm using the symbol that I have at 6, the parentheses, because it's not included, but I'm shading everything to the left of that. all of those values would work for both of the inequalities. So your solution set as an interval would be from -infinity to 6, not including 6.